let's go ahead. Let's see the shared key authentication. Now in shared key authentication, there is a shared secret between AP and station. Authentication phase now consists of three-way handshake. Now AP authenticates the station, but station is not authenticating the AP. So if someone is spoofing the AP, or if someone is saying falsely that I am the AP, client cannot come to know that whether I am talking with the actual AP or not. A simple challenge response kind of thing takes place. We will be seeing in next example, in next Wireshark trace, what exactly the difference between open authentication and shared key authentication. But if you are using web, then your first 128 bytes of the key stream for that IV are now known to all with this shared key authentication. Let's see Wireshark example first. This is the example for shared key authentication. Now if you see carefully, the packets are exactly same. The beacon packet transmitted by D-Link AP, the probe request packet, the probe response packet, the packets are exactly same. There is one more beacon packet actually in between. Now let's directly go to the first authentication packet, which is transmitted by Intel client to D-Link. Okay. Now if you see carefully, this is also exactly same packet as in the open case. The only difference is now client is saying the authentication algorithm is shared key. In the last example, client was saying the authentication algorithm is open. Now in the response to this packet, I'm sorry, these are beacon packets. This was the first authentication packet. Now in response to this authentication packet, AP will send a response with a tagged parameter. It's the challenge text parameter. So the authentication sequence will be again 2, but it will have a tagged parameter which is a challenge text. AP will send the 128 byte challenge text. Now client has to encrypt this challenge text with the shared key. If AP is able to decrypt the challenge text with the same shared key, and if the first challenge text and the decrypted challenge text exactly match, AP will send the authentication success message. Okay, so here AP has sent the challenge text. To this response, client is responding with the encrypted data with the challenge text. Now the data is 136 bytes because 128 byte challenge text plus 4 byte ICV plus 4 byte FCS. Now in the response of this, AP will send the authentication success because in this case the authentication was successful. So authentication sequence is 4, and for the shared key it's a success. Hereafter again the same thing, association request and association response will flow, and after that AP and station can exchange all kinds of frames. Okay, that's it about shared key authentication. Now an important question, if you are using a web association, is any extra frames flow between station and AP? The answer is no. There is a shared secret between AP and station, and either party will use that shared secret for encryption only. Now if you are using web, be careful. First change your encryption to WPA or WPA2. SecurityTube.net has videos for cracking the web key as well as flaws in the web. But first you have to change your security setting to WPA or WPA2 as web is broken. It's also called as worst ever privacy. Okay, that's it for this video. Thank you. Feel free to explore more wireless security videos on securitytube.net. Thank you.